Hello students, once again welcome to Waidsum University. This is chapter 5 part 6. Chapter 5 part 6 of this course, which is called the Interconnecting LANs. That's a local area network with the router. Interconnecting LAN with the router. Okay. Without much ado, let's begin. Let's take a highlighter and see what we can do. So we want to look at how to interconnect LANs, various LANs with a router. Okay, now first of all, let's have a router overview. We've done this in chapter 5 part 4. Chapter 5 part 4. We've done router studies. Now let's take a part 6. Now let's take a look at how to connect a local area network with a router. So in doing so, first and foremost, the first thing we do is to have an overview of router, what a router is. Remember we said router can route data, I said data based on the destination network address, not the MAC address, the media access control address. The router uses what we call the destination network address. Okay, this is very important to make routing decisions, right? You remember this? Router uses what we call the destination network address to make what we call the routing decisions. And this destination network address, remember, we also say it's called the logical address. So it's either we call it a network address or we call the logical address. So it uses the destination logical address rather than the physical address. The physical address could be the Ethernet address, or you call it the MAC address. Okay, they are usually the MAC address. They are the layer 2 addresses that is usually used by switches and bridges and hubs in layer 2. But routers, remember, they are not OSI model. They are not layer 2 devices. They are layer 3 devices. They are called the network layer. They are called the network layer. So they use what we call the logical address or the network layer in order to make routing decisions on where the destination of a data packet will be, where a data packet should be sent to. So routers, as we've studied before, uses what we call the network address or a logical address to make routing decisions, so determine where data packets will be sent to. Is that okay? Now we said the information exchange with the bridge and the switch and the hub in layer 2 switches requires that the MAC address for the host be known, because if you don't know the host in this case is both the sender and the receiver. That's what we call the host on a MAC system, on a network, or in LAN, okay, or in a LAN. So the host could be the source address and the destination address in a LAN. Okay, so in for switches system, when you use this switch, or in a layer 2 case, when we're doing layer 2 addressing, what we do, we need what we call the host MAC address, the two host MAC address. That's the computer where the data packet is coming from. We need to the bridge or the switch, which needs to learn the MAC address of the source where the data packet is coming from and the destination where the data packet is going to. That's for layer 2, okay, when we're using MAC addresses. But for router, it's not the same story. For router, first of all, use what we call the network address or logical address to make routing decisions. Okay, now router network such as the enterprise network, when we are talking about router network now, or routers, we're looking at enterprise network. By enterprise network, we are usually referring to large companies. That's what we mean by enterprise network. Or a campus network. You can also refer to a campus network. It's a bit also a large company. What they use is that they use what we call the IP addressing system, right? The network address or the logical address use what we call the IP address. They obtain the IP address and the locations of these IP addresses for what? For manage, or to help them manage the data movement. The IP address is to help manage what? The data movement, okay, where it's going and where it's coming from. Now, is that okay? Now let's take a look at the term network or logical address on computer allows the information to be sent from a local area network to a destination without requiring the computer to know the MAC address of the destination. So you can, if you want to send something from your computer using a router, IP address, a network address or IP address, address, you don't need to know the MAC address of the destination computer. But however, when it gets to the network, when it gets to the other network, the other LAN in another place, could be in another country, another city, okay, when it gets there, but still the routed data packet still have to establish within that network, still have to establish the MAC address of the computer. So in order for you to have the final delivery in the computer where it will be sent to. But however, when you are sending from one country to another, you don't initially be needing the MAC address. Okay, you just need to know the IP address, or what we call the network address. The network address or logical address help you to obtain the IP address from their locations, and help you route those IP address, help you route your data packets from your source, which is your host 1, to your destination, which is your host 2. Is that okay on a network? Thank you. So now let's move on quickly. Now here is what you see here is a network, various network connected with router. This is router 1, router A, router B, router C. Now you can see this router A is connected to router B, and router B is connected to router C, and router A is also directly linked with router C, as you see here. Then this creates the various segments. This router is connected to a switch through this port, through this interface, fast Ethernet 0/0. Okay, so through this interface it comes to this switch. Now this switch is connected with the computer A1, computer A2. Now you see computer A1, first of all, the interface, you see the port address of the local area network A. That's the local area network A, this one, local area network A. So this switch creates this local area network A. Now here we have the fast Ethernet 0/0, the fast Ethernet 0/0, which uses an IP address of, this is the original IP address that brings everything to this place, 10.10.20.250. Is that okay? So this is the IP address that the gateway address that this router brings this to this switch. Now we have the fast Ethernet 0/1, which is which we are going to describe here. This router sending this data packet to this other router, so that's another gateway, which is 10.10.200.1. okay, so then that's for that. Then we have fast Ethernet 0/2, which is 10.10.100.1. okay. Now this is for the gateway, the router gateway, okay, the various router gateways for this router A. Now the LAN computers, they all have their own delivery addresses, 10.10.20.1, 10.10.20.2 for these two, computer 1 A1 and computer A2. Okay, so these two computers on the LAN, they all have their own receivable addresses. Okay, that's that for that. The same applies to router B. Router B, you can see the fast Ethernet it receives through 10.10.10.250. okay, that's for router B. And then that's the gateway address. There has the fast Ethernet /02, so interface 02. This one fast Ethernet interface 02, and then it has its own IP address for that, 10.10.200.2, and so on and so forth. And another interface 210.150.1. okay, so all of this, then the LAN, this router B is connected to two LAN. You can see LAN B and LAN C. So LAN B has its own computer 1, 10.10.10.1 IP address, and then computer 2 has 10.10.10.2. okay, and then they all have a subnet mask of 255.255.255.255.0. This is subnet mask for the whole network, for all the network. We're going to study the subnet mask in chapter 6. okay, so these are IP addresses that are allocated to these various networking devices, as you see. So let's look at them specifically. Router B is also connected to LAN C, and then router D is connected to LAN D, and router A connect directly to router D, which connects to LAN D. Now let's take a look at what we have more specifically. Now router A, let's take a look at router A again. Once again, router A connects directly to the LAN A. Now from here, through this place, through this port, through this port, connects to LAN A via a fast Ethernet port of FA0/0. This one, through this port. Okay. That's how this router A connects to this local area network via this interface. Router A also connects directly to router B. You can see router A connecting directly to router B. This is router B, right? This is router A. So it connects through this interface FA0/1. Through this interface FA0/1. This one through this interface FA0/1. And they also connect to router C. Also connect to router C via, you can see router A here, router A. This router A is connected directly to router C. So look at router C here. Through this interface F0/2, FA0/2. So router A connects to router C via this interface, this port, FA0, this fast Ethernet, through this fast Ethernet. FA0/2. Is that okay? That's for router A. Now let's move on to router B. Router B connects directly to LAN B. Of course, you can see via which fast Ethernet port FA0/0. Now let's take a look at that. This router B, it connects directly to LAN B through where? Through this FA0/0. This place, this interface, this port. Via this port. Okay, router B also connects to router C to LAN C. So not only LAN B, it also connects to LAN C. Okay, connects to LAN C switch via what? Via this interface. Look at it, this port, via this port FA0/1, via this port. Now router B connects directly to router A. This B also goes back to A. Okay, you know, a router port is bidirectional. Okay, data can enter through it, data can leave through the same port. They are bidirectional. Okay, we've described that in the previous section. So router B also connect directly to router A via FA20/2. Then the same router B connects directly to router C via this port, this interface, this port, via this port FA0/3. Okay, so that you can see how routers connect from all angles, okay, to different local area network. Now let's move on to router C. Now if you take a look at router C, you see that router C connects directly to LAN D. Router C connects, this is LAN D, okay, this is LAN local area network D. So router C, this router C, it connects, this router connects to LAN D via which interface, which port? Via the FA0/0, right? Via the FA0/0. Okay, then router C also connects to router A. This C, you see, connects to A, straight back to A like this. Okay, through which interface? Through FA0/2. Through FA0/2. Through this fast Ethernet port FA0/2. Then the connection to route B is also provided here. Look at it, through this fast Ethernet port FA0/1. So this C also connect back to router B. Router C also connect back to router B through this fast Ethernet port FA0/1. Is that okay? Okay, let's move on. So we've shown how router connects to different local area networks, okay, or how they be used with various local area networks. Okay, now let's move on quickly. The serial port. Let's talk about the serial ports. The serial port like S0, S1, S2 are not being used to interconnect the router in any time you have a campus network. We don't use this serial port. Okay, this is not what we use to connect router. The serial interfaces are typically used to interconnect LAN. We use serial interface to interconnect local area network itself, not to connect routers to local area network. Okay, serial interfaces are used for what? They are used to connect to interconnect LAN, not to just connect local area network, not to connect routers with local area network. Okay, now let's move on quickly. We use serial interfaces for interconnecting LAN. You can use it here, okay, within this switch and the computer. You can use serial interfaces. Switch and computer can use it. Not okay. We don't use serial interfaces for connecting the LAN to the router. Okay, so that's the point we're making here. Okay, now let's move on quickly. Now let's go to routing table. Delivery of the information over the network is made possible by the use of what? The IP address. We've talked about this. You use the IP address and the routing table to deliver information. Okay, first of all, the IP address is to route the information from city to cities, country to countries, continent to continents. So when the data packet arrives at the network in the other continent or in the other country, then it uses the route table to establish which networks or which destination the information is meant for. So routing tables keeps the track of the routes to use the forwarded data to its destination. The IP address is to route the data packet from countries to countries, cities to cities, country to country, continent to continent, while the routing table is to establish the destination source, the destination where the data packet is sent to. Is that okay? Now let's move on quickly. So it uses the IP address to route the packet, and then when it gets to the network, then it will use the routing table to establish which destination is being sent to. Now let's talk about the gateway address. Now the term gateway is used to describe the address of the networking device. The address of the networking device. The networking device that you are using, the address it has is called the gateway address. Okay, and the networking devices that enables the host in a LAN to connect to the network. The networking address that enable the host to connect to a network. For example, the gateway address could be this one. The host in a LAN, the host in a LAN to connect to this network is called the gateway address. For example, we have one here, like this. This is a gateway address, okay, to connect from this local area network to the router. So you need a gateway address. Is that okay? So a gateway address is used for connecting networking devices to a host in the networking devices to the network itself, to connect it to the network itself. Okay, and also a host outside the network. So not only a host on the network, and also connecting a host outside the network. For all hosts in a LAN A, the gateway address is 10.10.250. 10.10. The host address is 10.10.250. That's the host address for all hosts in LAN A. Okay, this one is 250. 10.10.10. This is 10. Then .250. This is the gateway address. Is that okay? Now let's move on quickly. Now let's talk about the network segment. The network segment defines the networking links between two LANs. Okay, the segment defines a link. Look at you have a segment here, right? You have segment here, segment created. So you have a segment here, you have a segment here. It's like the link created in the networking system. Okay, so we said the network segment defines the networking link between two LAN. Okay, you have one LAN, local area network, linked with another local area network. That link is it's called the segment. Okay, you have here one local area network. Okay, and it's being linked with the help of this router and this router to another local area network. So that's a segment created. So a link is used. A segment is used to create a link between two LAN. Okay, there is a segment associated with each connection of Ethernet networking devices. There's always a segment always created or associated with each connection of the networking device. For example, when you're looking at router to hub, there is a router connected to a hub, then a segment will be created. A router connected to a switch, a segment will be created. A router connected to a router, a segment will be created. So whenever you use this kind of connectivity, then segments are created in a network. Now, the IP address of the network segment connecting LAN A to the router is 10.10.20.0. Now let's take a look at that. LAN A to the router, 10.10.20.0. This one. This is the IP address. Okay. Connecting this network, with a switch you already created a network. Connecting this LAN A, local area network A, to the router, is the IP address is 10.10.20.0. That's the IP address. Okay, so when we are connecting LAN A to the router, we get 10.10.20.0 for this particular network. Then all hosts connected to the segment must contain every other host on this segment. We have 10.10.20. maybe 1, 10.10.20.2, 10.10.20. till you exhaust the subnet mask of 255. Okay, till you exhaust, because your subnet mask is 255.255.200.0. This is your subnet mask. We're going to talk about subnet mask in chapter 6. So in this LAN A, the routing IP address is 10.10.20.0. So every computer connected to local area network A will be using this IP address together with the sub mask. Okay, with the subnet mask. So we'll be having 10.10.20.1, 10.10.20.2, like you see here. So this computer A1 on local area network A is you can see, let's see, 10.10.20.1, like that. So they will be using this. Okay, sir. Sorry. See the computer net address. These are the fast Ethernet interface, okay, of the router and then the switches. So look at the IP address of the computers: 10.10.20.1, 10.10.20.2. If you have another one for LAN A, 10.10.20.3, 10.10.20.4, like that. This will be the IP address of, till you exhaust the entire subnet mask that is designated for this network. Okay. So that's how it goes. Is that okay? That's how it goes. I've already explained them here. So these are the IP addresses of the various system. Okay, now let's. That's it. So that's it for this section. At the end of this section, we've talked about the network, enterprise network. We talked about the Ethernet port, and then we talked about serial port. That when you're using router, we use the Ethernet port. We talk about this type of port, and when you're using, we're just connecting LAN, we can use the serial port. And then we talk about the routing table for determining the destination of the MAC address. The routing table for determining the destination of the packet, data packet. While the IP address is to route the data from different local area network to another different area network. And then we talk about the gateway address. Okay, so that's all we have for this session. Thank you, and we implore you to join us in our next session. Thank you.